this chapter, we are working on functions and their graphs, and we're up to the graphing part. We know what a function is, and we know how to write an equation in function form. And we've also had a little practice setting up a function table to get a series of values in order to plot on a coordinate plane. We then spent some time calculating slope, and that's the slant or the steepness of a line. It's the ratio of rise over run. Our last part of this investigation included two unique types of lines. We found out that first off that there are the lines that have a positive slope, a negative slope, a zero slope, or an undefined slope. But the last thing we discussed in our last session was parallel and perpendicular lines. So let's go back to that for just a few more examples. Two lines are parallel if and only if they have the same slope. Now these equations are in function form or slope-intercept form. Y is equal to mx plus b. And you'll be hearing me use this equation or form of a line quite often now. M is equal to the slope. So if we identify the slope in each of these lines, and they're already in slope-intercept form, which is helpful. Line 1 has a slope of 2, and line 2 has a slope of 2. So we see that they have the same slope, so therefore they're parallel. And there's also a relationship between two lines that are perpendicular, ones that form right angles. And they are perpendicular if and only if their slopes are negative reciprocals. If you recall from last time, we changed the sign and flip. And we could also say that the product of these two slopes is -1. So let's identify the slopes in each of these, and if the equations are in function or slope-intercept form, that makes our lives a little bit easier because we just identify the slope in the first line as -3 and the slope in the second line as a +1/3. You see the signs changed and it flipped, so those two lines are perpendicular. Let's use what we know about these two relationships to see if two lines are parallel, perpendicular, or neither. So what we want to do is identify our slope in all of these. M in the first one is equal to -4. In line B, slope is 4. In line C, slope is 1/4. In line D, slope is a -4. And in line E, we have slope is -1/4. Now let's look at these a little carefully and see if we can determine if any of these lines are parallel. Well, parallel lines have the same slope, so it looks like line A and line D are parallel. They both have the same slope. Now here we don't have to do any work because they're already in the form that we could easily identify the slope. Let's keep looking at these, and we might notice that line B and line E are perpendicular. They're perpendicular because their slopes are negative reciprocals. I have 4, and I have the change the sign and flip. The question are there any others? Well, let's take a look at maybe one more. How about line A being perpendicular to line C? Again, -4 turns to +4, and reciprocal is 1/4, so A and C are perpendicular. Are there any other relationships that you can think of? Take a look at them carefully and see if there are any others. And as a matter of fact, I see that we could also say that, let's see if there's anything else. I've got the -1/4 and 4, -4. Oh, what about D? And C. D and C are also perpendicular. Again, their slopes are negative reciprocals. Now, there was a lot to look at in one slide because there were so many equations, so let's narrow it down a little bit to just comparing two. We'll start with the first two. Now, sometimes the equations are not in slope-intercept form, and you need to rewrite them before you can compare. So in each of these, they're in standard form. So let's just do one inverse operation on this one, and we'll get y is equal to a negative 2x plus 5. All I did was subtract 2x on both sides, and now I see that m is equal to negative 2. In my second one, step 1 is going to tell me let's move that 4x over by adding it to the opposite side. You then need to divide by 2 on all three terms. Y is equal to 2x plus 4, and m is equal to 2. Okay, so if I'm looking at this, I see that this would be neither. Because in one I have a negative 2 slope, and the other one I have a positive. So that's neither parallel or perpendicular. Let's go on to our second. Again, I need to rewrite this, so I'll start off by getting 3y is equal to 2x plus 3. I need to divide by 3 on all terms, and I get y is equal to 2/3 times x plus 1, where my slope is equal to 2/3. Second problem. Looks like I have just one inverse operation to convert this, and I get y is equal to a negative 3/2 x plus 3. And the slope of this line is a negative 3/2. The signs changed and if flipped, these two lines are perpendicular. So in the first one, they were already all in slope-intercept form. In our second grouping here, we saw that we had to rewrite them in order to identify our slope. Now let's take a look at two lines. Tell whether these lines are parallel, perpendicular, or neither. Given 2 points on the line, we have to calculate slope. So now they're making us work. All right, so let's take this first line, line 1. M is equal to. Now we just spent a whole section on this, so we should be okay with finding the slope. In line 1, I'm going to have 3, and then I add the opposite, and I'll get a slope of 1/2. So in the first one, m is equal to 1/2. Now I want to test out to find out what the slope is so I can compare. In the second one, I have y2 minus y1 over x2 minus x1. Add the opposite, that's going to give me 4/8, which is equal to 1/2. The line in the second, the slope in the second line is 1/2. These two lines are parallel. While we're in class, if we need to see some more examples, I have others to practice with. But I'd like to move on just briefly to what this is all leading us to, is the graphing. In this section, we're going to find out that there's a quicker way to graph a linear equation. Previously, we set up a table of values. I gave you the inputs or domain, you found out what the range is, you got the ordered pairs, and you graphed several points. You plotted them on a coordinate plane and connected the points. Well, the first method, that's called a quick method, it involves finding the x and y intercepts. Well, what are x and y intercepts? They're points that fall either on the x or the y axis. So again, if I have a coordinate plane, and we'll just do a really rough sketch. If I have a point that falls right here, The coordinates of that would be 2, 0. If I'm looking at my coordinate plane again, and I have a point that falls on the y-axis, this is now 0, and 1, 2, 3, 4. This is my y-intercept. And again, all I need is 2 points to graph a line. So I'm going to leave you with that. We won't do the graphing today, but we will work a little more on those parallel and perpendicular lines. This is where we'll pick up next class.